Welcome to CNC Underground After Hours, the podcast for people who live somewhere between G-code, production deadlines, and the late night question of whether CAM is replacing every binder in the shop. I'm Jessica, and today I'm joined with Jason Forsell, Director of Operations at Johnstech International. Jason has been in manufacturing since 1989, starting as a machinist apprentice before moving into setup, programming, and engineering leadership. Over his career, he's managed lathe, mill, Swiss, EDM, CAD design, CAM programming, and global projects in China, India, France, Brazil, and Mexico. Today, he oversees operations and leads a team of 25 Gibbs CAM users, and all while driving CAM as the single source of truth for process knowledge. Jason, welcome to the Underground.
Thanks for having me.
Yes, thank you for joining me. You've seen it all, literally. We're going to unpack what it looks like to lead teams at scale and why CAM strategy matters more than ever. But first, take me back. What was it like starting as a machinist apprentice in 1989?
Well, it certainly didn't involve CAM, but we did have a little bit of it. So I started as an apprentice with the old green screen style numbers less than 10 Fanuc controllers, working on old Mianos and LeBlanc. And even there was a little bit of CAM to help you. There was a symbolic FAP turn that was available from Fanuc, and you could go draw your part in the Fanuc controller, and it would give you some G codes. So even in 89, we had a conversational programming tool that could help you, but it was really cumbersome. And there were certainly a lot of things it didn't do, unlike today's modern CAM. So it had its place. You didn't have to be a geometry expert to find some of the hardest points, but every once in a while, even in the beginning, we would go out. The company I had only that. It had no CAD system. So on a drafting board, drawing up, if I needed to go find where a radius intersected an angle, sometimes I'd have to find that right on the drafting board and go measure it from a scale drawing. So we've come a long way from where I started.
Yes, I see why CAM is important to you.
Yeah, it's a key, I think, for it always has been a bit of a key, but in my most recent iteration here at Johnstech, it's really become what we've made the foundation of getting all of our process knowledge really put into that document. Not in, we call it, treat it like a document, not just a tool that we use on the side of many other lists or other things. This is the one place, retention of knowledge, repository for speeds, feeds, what the tools are. The entire process gets stored in the CAM.
Yeah, and that's so important because you have a big team over there, multiple shifts, right?
Yeah, so we're on a 3-shift operation, and the type of work we do is complex, and trying to be able to share information from part to part, and we make a lot of families of parts, keeping a lot of the critical knowledge together instead of making extra documents or extra guides. The CAM and template programs are really how we drive our business.
That makes a lot of sense. Are there any roles that you played in your career that really shaped you along the way?
Well, I think that starting as a machinist, and now I've been in management for a long time and been an engineer. Once an engineer, always an engineer, and once a machinist, always a machinist. Those are the critical things that make me an effective problem solver and thinker. Just like from the shop floor, you think about what you need to do to get something to work correctly. Using good methodologies and having a sound way to document what you've done is really built from starting as a machinist for me.
And I see that a lot with trades in general. I think that's a skill that is taken for granted, but the problem solving and really seeing something from the beginning to the end is really such a critical skill that people can have. And so it's important that we start with that, while kids are in school so they can develop that.
And we've hired here at Johnstech more than one applied engineering degree type of person also. So traditionally, when I started, there wasn't as many of those people out in the field. So you would get a degree in mechanical or electrical engineering, and you work your way backwards sometimes to learn how a machine tool worked. And now we have engineers on our, that work in my team, and I sponsored a group from Bemidji State of engineers that are people that are machinists and practical people that are getting applied degrees in engineering, 4-year degrees. And that brings them to the workforce ready as an engineer who knows how it's done.
That's great. I'm glad you're seeing a positive turnaround on that, because I don't think that was always the case, like you mentioned.
Yeah, just you would kind of be book knowledge smart after you came out of college, as the engineers are book smart and the people who do the work are work smart. Applied engineering degrees are really something that I've seen, and we have, like I say, my involvement with those programs over the last years have really been critical to bringing out people that already know how it's done and they have the engineering skills both. And so they can really hit the ground running and have great practical solutions.
I think I'm glad to hear that there's a 4-year option for people who still want to get into manufacturing. Oftentimes it's just seen with the trades. And, I think a decade ago we went through where the trades was a stigma and it wasn't the goal for a lot of people. And so there was a heavy push for 4-year universities. But I'm happy to hear that it works both ways and that you can go to trades or the 4-year or longer and still find your way to manufacturing. That's a good way to balance out who is in the market.
Yeah, and definitely I'm connected with Minneapolis College and their program that you can get an associate's, an AA degree for machining, for CNC machining.
Okay.
And then that AA degree leads to other programs because that's a 2-year school. So like Dunwoody, we have somebody who's currently enrolled getting their 4-year degree building on that. And it's an applied degree again, but it's a 4-year industrial engineering degree. So there's good pathways. Like I say, I also worked with Bemidji State this year, and I sponsored 4 students out of their applied program for their people that are working, that have gotten a 2-year degree, and then gone back to school, people that are maybe, 30, 35, 40, mid-career even. People go back and enhance their education. So there's a pathway starting with the trade part of it, and starting with, even if it's a 1-year style get to work now kind of program that's out there, there's those programs can lead to 2-year programs, can build to 4-year programs. And you come in with practical knowledge at each step. So that A in front of your degree, that applied part, which is really something that's a Europe concept also. That's where a lot of those degrees come from. And those are people that started as apprentices and then built their university career moving forward. So I'm glad to see that the healthy programs at Minneapolis, Dunwoody, and Bemidji that I've been part of over the last few years.
Yeah, that's good advice for young listeners and young people getting into the trade. So I'm happy to get the word out about that. I wasn't aware of the applied portion of it and how it had such an impact. And so that's a good outlook too, that we can push out there more.
Yeah, we've had really good luck here at Johnstech. We've sponsored several. We had 8+ interns from Minneapolis College with our partnership. They're formerly MCTC. There's a story this year at WCCO about some of the women from the program that have been here at Johnstech. And it's really been a great program that it gets a good group of people from a diverse background involved in trades.
I love any shout out to women in manufacturing. The more we get that out there. And you guys do, I would say overall, the largest group of women in manufacturing that I've seen. So that's admirable as well, that you guys are open to all of that and that women are getting up and coming and seeing that they can participate too.
We've been lucky that those have been the top candidates. It's really been fortunate for us that they're involved, and Minneapolis College specifically has a great program. They were started as a college that was helping women in the trades, that they'd started helping because Minneapolis had a lot of women in the trades. Munsingware used to be very close to where that's located, and they train people for learning how to work on technical things on the factory floor of Munsingware and that kind of work.
Yeah, I love that. What's the biggest change that you've witnessed in manufacturing?
Well, I can say that automation and the application of CAM and technical tools have been a slow moving train. It seems like whenever you had a computer at your house, it was faster than your controller at work, or hey, I had a better graphics card in my phone than I do on my machine. And we always kind of thought, and I think in general, technology has always been kind of future. People think the future is coming faster than it actually did. And it's starting to really get up to a point with the technologies that we have in CAM and the controllers on the machine that your iPhone's still probably smarter than faster sometimes, but not the same gap. And that and the changes we've seen over the last 5 years from Industry 4.0, Internet of Things, and the AI, some of those details are now really starting to have an impact on our industry. But in 1989, we thought that that was all coming in a few years, and it was a slower moving train to really reach the shop floor, and it's really started to arrive now.
Yeah, I agree. And there's so much room for improvement yet to go. We see so much with additive, and that's really taken a step forward. And now that's making, I think, CAM and subtractive just take that leap forward too. And it's becoming more popular in general because of all of the automation and AI, and people are just more aware of it now than I think ever before.
Yeah, I think people have really adopted, because you think about additive or mold making where you would work from the model, and some of the other subtractive people, I work from the drawing and I do my own thing. The adoption of really working from models only, the adoption of using all of the tools and being able to have everybody engage with those tools has really started to take off over the last 5 years, especially.
Yeah. How do you think that CAM can replace binders, spreadsheets, tribal knowledge?
Well, that is exactly what we adopted here at Johnstech. So I've been here now coming up on 4 years, and Johnstech was already a user of CAM at each workstation, but that is exactly the point that we've made with our CAM files, to say that we do not want to have a setup sheet. The CAM is the setup sheet.
Mm-hmm.
It has the information of what's the accurate tool descriptions and accurate material files, and you can work from the CAM only for all of the process that you need, and making the CAM the document of what are the parameters and making all the notes in the CAM. So the CAM allows all kinds of different ways to make all the kind of notes you would have put in a spreadsheet or a binder or a setup sheet, and eliminating all those. So we're not using any of those tools anymore. The best practices and all of those details are retained in our CAM practice.
So do you find that any one of your programmers could pick up where someone left off because of how you're documenting?
Yeah, and moreover, all the machinists here interact with the CAM, just not with the solid model license. So having a scaled version where everybody interacts with the CAM, which I know we're unique as a manufacturing operation to say that everybody's got 2 monitors and has a key to be into the CAM, and there's a cost associated if you're working with the solid model, but without the solid model, that lesser key lets us give it all the other information right in the CAM system, and that's our strategy here.
If your machinists are using it specifically to view anything, the posted code, the program itself, we should talk about the Gibbs CAM viewer that's coming out next month too, because that could be something that's really beneficial to you guys.
Sure, yeah, because we're definitely always looking for a way to help them. And again, the key for us is we're eliminating all of that. So I think somewhat uniquely, there's not a lot of other people that have committed to every machinist interacts with the CAM, but that is our strategy here.
I think it's a beneficial skill though, because then they know what's going on, and it might be easier to set up the machine and to check for errors if they interact with the CAM and know exactly what's going on.
And that's exactly what we want them to do. And our programs can be long and complex. So trying to go to the controller and find all your feed rates, hunting through the old school way, and you missed a feed rate, or trying to make adjustments for a lot of things that aren't conducive to a CAM cycle. You want the CAM to plot all the paths. Those are the things that making accurate edits and accurate changes, and those things are needed in a lot of the challenging manufacturing that we're doing here. It's if you've got that kind of challenging part, CAM is a key for us to making sure that we can even just adjust the program accurately.
So how does that go along with G-code? Because there's a running debate online about whether G-code is still important. Do your machinists know G-code?
Yeah, so people do know G-code, and it's still somewhat important, but we're relying on making our post processors work correctly. You still have to know what the machine's going to do. We still tell people to single lock programs through and not just hit the button and look like it was going to be great on the screen. But with that said, we're not reliant on that. The CAM provides effective tool paths. And when we're looking at it at the machinist level, we're clear that we can see where the tool is going to go. We know what the code should do. So many times you're just making sure you've got your work coordinate correct. You're getting your first safe position, and then you're letting the program run with minimal G code editing. And most of the posts, it's very rare that we think that it's done something funny. It reminds me of old Mesa Trolls without the G code post processor. Everybody'd watch the machine sometimes move around in outer space because it was trying to make a bunch of safe moves for you. We're not finding that with Gibbs. It doesn't make a bunch of irrelevant moves, or we need to air cut with it. And short of like high volume turning and things where you might want to do something that's really trick outside of the cam, like try to make the turret index while it's retracting, or do some real microsecond or few second types of nips that the cam's not designed to necessarily help you edit out. The cam provides you the right code, and especially with milling, we don't find that we have to manipulate that. So G code debate, you have to know what all the codes are, and I still make people know if it's going to go in rapid, or if you're interpolating. And we still want people to know if the machine's going to get you wet with the coolants if you have the door open. But the key, the backbone of getting a process is to use the cam in our plan here.
Yeah, I like that you guys have adapted that, and I hope more people continue to see the benefit that cam offers, because it's just going to continue to get better in the future.
Yep, we're excited about improvements, and we have a list of things that we want cam to grow and change with. A key for us, I know, is to have a strong universal tool library that we basically can build all of our tools once, and it's easy to go find them, and a strategy that says, hey, we always like to configure this tool this way, this holder, this stick out, and all of those things, and be able to readily pick those up. Because we do find that we use the same, 200 tools over and over for the most part. So we're working on all those strategies to improve those and streamline those in our material files. A lot of other, it's a continuous project for us, and we're excited about all the new tools coming to help us be better at that.
Definitely. I have a couple solutions for that too, so we should talk later about that. A couple new partnerships, as well as some other options within Gibbs that we might be able to help with that.
Sounds great.
Yeah. All right, let's do something fun. It's a game I made up just for you. It's called Binder or Cam. I'll name a shop scenario, and you tell me if it used to live in a binder and now how Cam can handle it.
Okay.
First scenario, setup sheets for complex Swiss jobs.
So that definitely used to live in a binder and now lives in Cam for sure in what are our applications. And the key there is, again, making, all the notes in the Gibbs program, all of that data of how to set the tool. And those are the things you expect in setup is, how far did you really have that tool sticking out, or, things that are more subtle than just I used CCMT insert and what the name of it was, but all that data can reside in there too. So a lot of that information, we just put all the notes in the cam. That's the way we live.
And I can't speak for other cam systems, but there really are so many places, in Gibbs Cam specifically, where you can put notes. The operation, the tool, the process, all of it can have notes. So really, that makes a lot of sense that you would host it in there.
Yep, that's where we like it.
All right, number 2, tool lists for repeat parts.
Definitely, again, resides in, we like to call those, programs, template programs. So making programs that have that those tools racked up, and call that a template program, and just label that in our program file system. That's where those all live. So definitely not in a binder, right in Cam for us.
Definitely. Revision tracking for aerospace or 5-axis work.
Well, our 5-axis work, definitely, again, it's all in the nomenclature in the programs and in the notes in the programs.
Good. And the last one, knowledge from senior machinists.
This is critical to really live in the programs and in the Gibbs Cam programs. And this is one of the keys for us is all the little tips and tricks that you get from the senior machinist, and people that say, well, hey, you really got to choke this tool up like this, or you got to have, you got to take 3 passes instead of 2, or you need a spring pass. All of that is in the CAM with notes, so people understand. And sometimes those aren't universals. It's like maybe because materials are not a constant. If you run a material that has a tensile strength that varies by 30 or 40,000 KSI, it's from 85,000 to 115,000, and maybe it comes in different heat lots. Sometimes it wants to chatter. Sometimes you got to go faster or slower. But keeping all that data of, hey, it should be between this speed and this feed is what our known parameters, or start here with this lot and see what you get, because those are the kind of interactions that all of that detail, if it lives right in the CAM and the program as they're running it and they're interacting with it, we found that to be the best way to get that senior knowledge, all of those details. I mean, as I learned in 1989, if it chatters, you're going to definitely want to make sure to increase the feed or decrease the speed. But what are those parameters? Where would you go with that? And every part, like every unique part, has its own proposition between material properties and diameters you're working with and tools, all of those. So in the CAMs where all those, we'd like to have those live. And those are the kinds of things you get from the experienced machinist. So we're having to dump that in there. That's where we're getting it retained at.
It's important to have it all in one place, I think, right? So then you're not searching. So we've all probably seen a super old binder somewhere laying in a shop, but what's in it? Is there a more efficient place it could be that someone's going to look for something in just one place? Save a lot of time, make sure that it's all there and detailed, especially now with all of the retirements that are happening. We want to gather all that information while we can.
Definitely. We've had several retirements in our organization, and they've been on the mission to make sure that we're getting that retention of knowledge. The retention of knowledge document is the CAM system for us.
Makes a lot of sense. What is it like leading such a large CAM programming team?
Well, it's challenging to make sure everybody is doing it the same way. So as CAM users know, there's 3 or 4 different ways sometimes to approach things. There can be variation. And so we allow for some variation, but making sure that things are thoroughly documented in the CAM program makes it so everybody as a user can come pick back up. And then the other thing too is kind of like, I think most people know how to use Microsoft Office products like Excel or Word. And I think I'll use Excel as an example. We encounter people that are really good at it and some people that are okay at it. Most people have some large amount of self-taught knowledge. We have found, not to get off on a promotion for your team, but making everybody get the same training from the same curriculum, and we are using Midwest CAM for that, really gets everybody aligned so everybody knows what our 3 good standard practices, and it lets people pick up behind each other. And even people say, hey, I know how to use Gibbs CAM. We have found it to be important to get everybody to have the same educated curriculum. So once they have that, I even took the CAM class as a longtime user only a few years back to make sure to just see what the class was. And yeah, I knew a lot of it, but I picked up 2 or 3 things even from that. And the value was that now I understand, along with my team, what they get out of the training and what are the, hey, here's 3 different ways you can achieve this. And we can all have a discussion around which ways we prefer and which ways are acceptable. And it helps everybody do it the same way.
I love that you took it. Yeah, I love that you took it too. That makes a lot of sense. That's a good attribute for a leader to know exactly then if you're requiring your team to do it, then you would do the same. So I really like that you took the course too.
Yeah, I was glad to give it a shot, and I wanted to make sure that everybody that I asked to go take it, I could intelligently speak to, and it's not a ton of time. I think it was 24 hours. It wasn't terrible for us to put that together, and you've got it in a good format where it's spread out over typically 6 weeks. So it's doable. And that we've made the commitment that we say it's doable for everybody who's a user of CAM to get at least the basic, either turning or mill basic, depending on what kind of work they're doing. Get that foundation, which takes you all the way through shrink wrapping a model and programming at the end. So it's a good overview of the entire process, even if you're not an everyday programmer.
And I preach and preach, especially on here, that investing in your team is so critical. It helps with employee turnaround and productivity and efficiency. And so I love that you guys are investing in your programmers and machinists and everybody, because it just overall will help your business grow and be more successful.
Yeah, people take pride in having that external education with their own certificate and knowing that they're, have been certified by the manufacturer of the CAM, not just an internal class. Yeah. That independent curriculum gives everybody something that they can hang on to for their entire career and is something that's specific from the manufacturer. So it's great.
Yeah, I hear you. I took CNC courses after I started this job a few years ago, and it was the same. I was so proud that I was like, I have these certificates now, and I actually know a little bit about what's going on, but it really is a motivation and confidence boost when you go into what you're doing then, because you earned it.
And we find that we have people interact with the CAM a little bit with people telling them first, so that we don't have people go in who's never seen CAM at all. And they will get some information. And then during the 6 weeks, they're actually using CAM at some level every day at work, and they're getting the lessons. So that combined, applied, I'll use that word applied again, like the degrees or like the work that we're doing. It's really applied science. It's applied education. Having that combination of using it and learning at the same time really is great. It makes really effective, CAM users.
Mm-hmm. How do you keep them engaged then while enforcing those standards?
So I think that most people, we haven't really had a problem with most people that once they have the right information, people can follow along. We think about when programs, I've worked at many operations and been involved in many operations where 3 people program 3 different ways and they got their way and you have to learn their way. I don't find that people don't, the rules of how CAM is laid out, people conform to that. It's not like they're working hard to go outside of it. And when we don't like what a post processor would do or what the CAM thought, we come up with creative ways to express it through the CAM system, though. Not, there's no real manual G code edits or things we have to override. Mm-hmm. CAM has evolved enough that you don't have to override what it does. I think about things like I like to program every pass when I thread versus using a CAM cycle or things like that. You can get the CAM to express all of those things that are your preferences.
Yeah, I like that. That's a good note. I think that you really can do everything you need to inside of it. And even if you aren't happy with how a post is outputting, there are ways to modify that. Even if you don't know G code, that's what your CAM provider's for, to assist with that.
Yeah, definitely. We've had a couple custom post modifications since I've been here and creating posts, but in general, they've been strong out of the box. We bought new machine tools that didn't even have a post, like, hey, this is a machine tool. It's not supported by the post. Those were effectively put together. And after a couple iterations, we've got ourselves a great working post and we have all the tools we need.
Yeah, I'm happy to hear it. Let's do another fun one. Would you rather CAM edition? I'm going to give you some scenarios and you tell me which one is the better of 2 evils.
Okay.
All right. Would you rather fix a corrupted CAM file at 5 p.m. on a Friday or rerun the first article inspection with a customer watching?
I never want to check a part with the customer, so I'd rather rerun. I think that's one of my principles. Hey, never inspect parts with your customer. That's always uncomfortable.
I hear you. That's a good choice. All right, next one. Train a brand new machinist in GibbsCAM or explain to leadership why a cycle time doubled overnight.
I'd rather train somebody than to talk about how long things got, for sure.
Would you rather run a shop with no CAM system or a shop with 5 different CAM systems that nobody agrees on?
I think I would probably go with 5 different CAM systems because at least we've got some common language there.
Yeah. Would you rather rebuild a broken post on your own or sit through a 3-hour tool library meeting?
I think I take the tool library meeting for sure. I want to make sure that we're using the process and not figure it out myself.
And the last one, would you rather type G code all week or sit through an ERP kickoff meeting?
Oh boy. ERP kickoff meeting, I think, is fine. I take that. I miss writing code from 1989 or old days, but I'll take the meeting.
I love it. Thanks for doing that with me. That's fun. You've worked in China, India, France, Brazil, and Mexico. Was there a specific place that stood out for shop culture?
Well, I can say that as I worked in places like, I'll take Brazil as an example, the culture there is to have really strong control of the process through the organization. So people stay in their lanes and they have a really strong engineering focus. Where when I worked in France, people were empowered more on the floor to responsibly report their changes, and certainly even things like gauging method on the floor. People in France, I found that uniquely, those people who went through long apprentice programs, so people in Europe, France, Germany, a lot of times that they were apprentices in high school, or at a younger age, their gauge R&R ability was a lot stronger. So you could tell somebody to check something with a caliper that you need a micrometer for a larger mix of users that aren't as highly skilled. So those are a couple of things that I saw that are different on the floor.
Yeah, they do start, the way they structure school over there is very different, I believe.
Yeah, so you can make a declaration at, ninth grade that you're in the trades at that point. Definitely in Germany, still that's the case. And so you may encounter somebody who's in 10th grade working in the factory as part of their school day. So trades start earlier there.
Yeah, but but what a way to become successful earlier in your life that way.
Yeah, and just building great skills. Like I say, maybe they could check plus or minus 5/10 with a caliper, which we would never do here. Say, no, but nobody's repeatable with 3 people on that, but maybe 3 people there can pass a gauge R&R and doing that. And that comes from early training sometimes.
Yeah, wow. Did you see any challenges that were universal across all of those different places?
Well, certainly, materials and variation in process is the same in every shop. So even with a lot of times I would see the same machine tools in different places, a lot of finite controls, a lot of the, same global tool suppliers, but some of the same challenges with, material is still, like in the previous example where I said that yield strengths are different or material variation. Those are, everybody encounters that, and sometimes jobs don't go exactly as planned, especially with challenging materials, because it's not always the same, lot to lot. So the skill of the machinist is identifying those items as they come up and being able to react to that.
Interesting. Yeah. Was there anything that was a really big contrast from the United States?
Well, machines are machines. So I would say that, and I found that people who, especially in CNC machining, people are universally have some sort of qualification or engagement. So I found it there's more similarities than something that was like, oh, hey, they really do something different. And between that and ISO and other things that are adopted in all those places, so China, India, anywhere that I would go, people were using those same international standards of how they run their business. And a lot of the same stuff was the same, even if it was, like when I was in Europe, there was a lot of Spain. Spain was a big machine tool manufacturer with finite controllers, but it still was the same type of code, same tool suppliers, and every once in a while I'd see even, familiar things like a command tool holder or a Kurt vise or a Haas mill, things that not as much, they're mostly different brands, but once you get past that part of it, same stuff.
Run similarly.
Yeah. Mm-hmm.
Huh. So we've talked about G code and critical thinking, problem solving skills. What are you thinking are the most important skills for people who are upcoming in the trade to focus on?
Well, certainly getting a good, solid education on how tools work. I think that the programs that are offered by a lot of the tech school programs, maybe people don't think are as glamorous because you may spend a lot of time on a Bridgeport, or I'm not really using the CNC right away, but learning how tools work and getting those real basics. I started as an apprentice, started getting handed a file to go file off slugs off the saw before I was on the CNC, and really understanding all of that, the basics of how things work from a cutting and basic tool action before it becomes just on the screen and it is all on the computer, if you will. That is a key to really understanding how things work, having material and getting that basic kind of material in your hand and putting a file to a piece of aluminum versus a piece of steel, or really actually having the feedback through the handle on a Bridgeport when you're actually cutting something, really, because you're never going to get that when you go put it in the CNC.
No.
So those, I found that those were important things for me to get, and I'm glad that people who enter the trades now go get those hands-on skills. So combine that with, now I'm getting all this really strong basics feedback on how it works, and then starting with being good, always good people who talk about data and being able to articulate yourselves, because that's really a key also. Being able to describe what's happening and share that with the team is the other big thing, because those two things, understanding what it should do and what it is, and communication, we can work with anybody with those two skills to become great machinists.
That makes a lot of sense. And I can relate it back again to when I took those courses. I had been with Gibbs for about 5 years before I took them, and I would watch demos, and I did a lot of maintenance before then, and I would watch the demos and just be like, I have no idea what's going on there. And I tried to take a programming course and I was still like, I don't know what's going on here. And then I took the CNC courses and it all started to make sense. Even the conversations that I was having with people, everything just added up. So really going back to the basics is so beneficial and so helpful. By no means am I an expert in any of it, but I can hold a conversation and understand what people are talking about now. And I know what the demos are showing. And thankfully, I still have my team to do support, but I at least know what people need and how to help now.
That's great.
Yeah. All right. What do you think will never change, no matter how much CAM or automation evolve?
Well, certainly understanding the process of what's really happening at the point of either additive or subtractive manufacturing. The CAM doesn't know all that yet. And you have to understand really how those things interact. So I don't think it's going to change how a drill works or how an end mill works or a turning tool or any of those items. Those aren't the things that change. But the CAM part of it is continuing to change and get better at really being able to describe all the things that you want to express in the program. So you can do that through all the parameters. You can tell the CAM now and how smart it can be. And really getting an accurate set of information, a library into the CAM really is the kind of the bicycle for your programming mind. It's not going to take, you're still going to have to pedal, but you're going to do it a lot faster and you'll be more efficient.
Yeah, I agree. I have one more question for you, and we talked a little bit about this, but if there was one thing that you wish CAM could do right now, what would it be?
Well, I wished that somewhere CAM had the ability, and this is probably kind of out there, but sometimes we're trying to be conscious of what the tolerance is, not just what the model's thinking. So in general, my desire for CAM and CAD is to have a smarter connection between tolerancing and what the model is, because that's kind of a missing link when you go to write a program. Is you'll see a feature, and yeah, I'm just trying to get to that feature, but how tight am I trying to hold that feature? And should I be conscious of a geometric tolerance? And do I really want to run at maximum material condition? Or all of those targets, having some link between those. So they talk, and the CAM can acknowledge that, and it acknowledges your programming strategy changes, because that is the one thing that we end up doing sometimes, is having to make those kinds of changes. So, hey, I got to run that on the big side, or hey, this is going to taper. I'm going to need to come up with a strategy on how I manage taper, and maybe I want to be able to offset my taper. And those are the kind of things that people start going in and either having to change it directly in the CAM, telling it that the part's a different shape or some other thing. So facilities that allow you to understand tolerancing and geometric propositions that require changes sometimes, that would be the next cool thing for CAM to do for me.
I like that. And I had a demo with UpToParts. I don't know if you're familiar with them yet. They're up and coming in the States, and they have automatic quoting that's through AI as well as AutoCAM. And I saw the coolest capabilities with tolerancing that I've never seen before. So we could talk about that too, because I think that could be.
But yeah, that would be cool, because that's exactly it. That's the whole thing, is to be able to take kind of what all the tolerance, what the print says, which is most of the time that all that data is residing, somewhere else. It's not necessarily attached in the model in an accessible way. Many people are just getting a PDF.
Yeah.
But, hey, I go work on that. So making a cool connection about how they, like you say, I could imagine, but I don't know anybody's got it working, that the AI goes and reads the print, or something else is connecting it back to the model and allowing that to drive all the things, like you say, from estimating to quality documentation to inspection to even the process. So even focus just on the process. What do I have to pay attention to? That would be great.
Yeah, I think that's all the stuff that's up and coming, and I think some of it's starting to arrive now. So we'll definitely talk more. Any final thoughts?
No, I'm just glad that we had a few minutes to chat here, and hopefully users out there can take our example over here at Johnstech of being really embracing CAM and find ways for that to work for them in their organizations.
It really is a great example, and I appreciate hearing all of it and the strategy and thought behind it. I think it's a smart way to document and to know all of the important aspects that future machinists and that will need to know in your facilities, and people could take note. So it's been a lot of fun, and I think they're going to have a whole new way of thinking about CAM strategy after listening to this. So I'm excited for our listeners to hear everything you had to say.
All right. Thanks for having me today.
Yeah. So that's it for today's episode of CNC Underground After Hours. Until next time, keep the coolant clean, the deadlines close, and remember, the best process knowledge doesn't live in a binder anymore.